So hello and welcome back. So in this example we have another great example from the Khan Academy, and the question is, Fred started studying how the number of branches on his tree grows over time. So it's about growth, and it's about growing the number of the branches of a tree. So the relationship between the elapsed time in years, let me see. Elapsed time in years, so time t in years. Since Fred started studying the tree and the number of its branches, b of year of t, so it's the number of the branches of the tree, which is b of year of t, is modeled by the following function. So the function is b of year of t is equal to 20 times 2.5 raised to the power t. Now the question is, every month the number of the branches increases by a factor of what? So you need to pay attention to the fact that time here related to this function t is in years. It is in years. But here the question is asking about month. Every month what's happening. So it's again the same situation as a previous video that we had. So if you haven't watched that video, please do so that I don't have to go through a complete analysis of this, or I could do it, but I'll do it briefly. So basically, again, you have a function here, b of year of t, which is equal to 20 times 2.5 raised to the power t. Now, so what this function does is that the initial number of the branches was 20, and every time you increment your t, another factor of 2.5 is multiplied by the number of branches. So when t is equal to 0, you have only 20 branches. When t is equal to 1, then you have 20 times 2.5. When t is equal to 2, the number of branches becomes 20 times 2.5 times 2.5. So over time, as you increment your t, your b of year of t is being multiplied by 2.5, again another 2.5, again another 2.5, and so on and so forth. So this function is perfect if you want to study the number of the branches of the tree, as long as your input refers to years. For example, you want to know what happens after 1 year, or after 2 years, or after 3 years. But this function does not give you accurate information or any sort of information about what happens, for example, after the 8th month, after the 9th month, after the 10th month. So if you want to, now that you have built this function, and you know that a month or a couple of months is just a fraction of a year, so based on this information, you can build another function that gives you information based on inputs relevant to months, not relevant to years. So what you need to do here is that you need to basically construct another function b of month of t. So here again, your input becomes months, not years. Here your input is years. And this is equal to 20 times 2.5 raised to the power. And then here you need to decide. So here basically your input was years, and here you had t based on input based on years. But since there is, I'm actually basically making some changes to this function to make it a function based on inputs relevant to months. So there are basically 12 months in a year. So since there are 12 months in a year, you have to divide t by 12. So now if your input is equal to 1 in this function below, so if your input is 1, the input goes into this function. We have not made any changes to these numbers. It goes over here. So over here, t is divided by 12, which means 1/12 of a year. 1/12 of a year, and then it gives you some sort of output that is relevant to months. If your input is 12, for example 12 months, then it becomes b of month of 12, and then it becomes 20 times 2.5. No changes still here, and then it becomes 12 divided by 12. So 12 divided by 12 is 1, and then basically 1 goes over here, so then it becomes basically 12 months, and 12 divided by 12 is 1, and then 1 factor of 2.5 is multiplied by the output of the function. So if you think about it, it's basically the same function, only I have divided the variable by 12 so that so that I haven't really made any changes to this function. I have just made some changes to the input unit, and then based on that I have made this change to the output, to the variable inside the function, so that it corresponds to the original function. So now let's see what happens here. For example, if you have, based on this function here, let's call it 1 and let's call it 2, for example. Based on this function 1, if you have 1 year, if you think about 1 year, so that then this becomes b of year of 1, because the input here is year, and it's equal to the output of the function becomes 20 times 2.5 raised to the first power. Now the same, if we have made this function right, if we have constructed this function right, we are supposed to get the same output from this function. So here we were talking about 1 year, so basically 1 year becomes what? Becomes 12 months. So based on this function, so this was basically 1, and based on function 2, b of month, and then 1 year is nothing but 12 months. 12 is equal to 20 times 2.5 raised to the power t by 12, which is basically 12 by 12, which is equal to 20 times 2.5 raised to the power 1. So it's again the same function here. These are equal. So basically we have created this function right. Now there is one problem here. Now this was a function that I needed in order to answer the question. Every month the number of branches increases by a factor of what? Now the factor here is not trustable, because it's still the same factor that was present in the previous function. So now I need to make some changes to this function to take care of this factor, because based on this function, every month a different factor is being multiplied by the output of the function, not 2.5 but way less than 2.5. So what happens here is that you need to, so basically you need to rewrite this as b of month of t is equal to 20 times, so you have 2.5 raised to the power t by 12. And let me see what I can do here. So you have basically a raised to the power b by c. So I had to think for a while, not for a while, for a few minutes to figure this out. So what happens here is that I want to rewrite this so that I have only the variable as the index. The index right now is t by 12. I want to make it only t, so that I can know what is really being multiplied by the output of the function every time I'm making changes to this t. So basically what I have here is 2.5 raised to the power t divided by 12. So I can rewrite this as 2.5 raised to the power t times 1 by 12. And then I can rewrite this as 2.5 raised to the 2.5 raised to the power 1 by 12 whole raised to the power t, because a raised to the power b into c can be written as a raised to the power b whole raised to the power c, or it can be written as a raised to the power c whole raised to the power b. So based on this you can rewrite this. You can rewrite 2.5 raised to the power t into 1 by 12. You can write it as 2.5 raised to the power 1 by 12 whole raised to the power t. And then you have 2.5 raised to the power 1 by 12. 1 divided by 12, which is 1.08. Basically rounded up to 2 decimal places. So this would be 1.08 raised to the power t. So now I can rewrite this equation as b of month of t, which is equal to 20 times 1 times 2.5, sorry. Instead of 2.5 raised to the power t by 12, I can write this, which is 1.08 raised to the power t. So now you can see that for every change, for every incrementation that we make for every time we increment t, another factor of 1.08 is being multiplied by the function, which means the function is being increased by 8% every time t is incremented. So the answer here is every month, the number of the branches increases by a factor of 1.08. So that was an interesting problem. So thank you, and I'll see you in the next video.